Greetings, citizens. This is Trip Rodriguez of twitch.tv/Trip Rodriguez with the Ultimate Warthog Gimbal Improvement and Repair Guide. For this project, you will need the synthetic marine grease. You can get it to any different brand, but what you're looking for is the thickening agent, specifically calcium sulfonate complex. Has an NLGI of 2. That's the thickness. So go ahead and start opening up your Warthog here. Be very careful opening it up if you use power tools. Probably not advisable to use power tools. So don't use them unless you're extremely confident in your ability to be very, very cautious and make sure that you don't strip anything out. For this guide, I'm going to focus on what I do differently from other guides. I believe I have a significantly improved way of eliminating the stiction problem that the Warthog develops. You can do this in advance or as a repair after it has started. You can also sand down all of the gimbal components, and I'll show you where specifically, to make this Warthog smoother, get kind of rid of that gritty feel it has to it a little bit by removing some of the texture. I think that that texture helps retain the grease somewhat though, so I'm not 100% sure that that is worth doing. I did it on mine and it feels great, but I have to move it around vigorously occasionally to spread the grease around a bit. Note these 4 rubber pads inside the plastic ring. Those help retain the spring, keep the spring in place. They go up. They're at the top of that plastic ring. As you take this apart, note this rubber ring. This is the second problem that crops up with Warthog joysticks. This ring will delaminate, separating into layers, and start causing problems with the centering of the joystick. You can just remove it and leave it out if there are any problems with it. Leaving it out will just make the center bump a bit more harsh. Note these 4 holes in this plate here. Those are 4 of the holes that we are going to be boring out a little bit larger to avoid future problems with the joystick sticking and not working smoothly. Now that we've stripped the gimbal down and there are no longer any springs affecting it, you can feel the gimbal function here by itself without anything interfering, and you'll notice even if it's brand new, moving it forward and back toward and away from the wire is going to be very, very light and smooth. We're moving it the other way, you will find it has a lot more friction, and if your Warthog is suffering from the Warthog stiction, you'll notice the stiction there where it's kind of sticking at points. Eliminating that stiction is our main goal here. Next, we're going to take apart the bottom of the joystick to free up the wires so we can pull the gimbal apart without tugging on any wires. So I'm going to take a marker and I'm going to mark where the little circuit board here is installed. It actually can be installed on either side. The holes are symmetrical. So we're going to go ahead and mark that and take those off. And next we're going to remove the 2 ground wires, 1 screw for each. Now that the wires are freed up, we can pull the gimbal apart. Just grab a hold of the top component here and pull straight up and just tug on it until it pulls free. Moving this back and forth with your fingers, you should actually feel the friction in it, and if it's a used Warthog, it'll be kind of sticky. And that is the infamous Warthog stiction problem. We're going to pull the sensor assembly out. This is where the Hall effect sensor is mounted. These are the 2 screws you have to be the most careful with. They're the ones that are easiest to strip out and will cause you some serious problems if you do that. So be careful with these, especially when you're putting them back in afterward. We're going to take our black marker and mark which side the wires go up on. There's actually a notch there in that tower for the wires to go through. And when I pull this out, you'll see the magnet has actually fallen off of the gimbal in this particular Warthog and is down there on top of the Hall effect sensor. So just ignore that, that is unusual. The next step is to knock out the two pins that actually cause the stiction problem. I use these bent pliers to do the job, but once you see the way it comes apart, you might be able to find something else that'll get the job done. These two plastic pins that we're removing right now are actually the source of the Warthog stiction problem that everybody talks about. Because this innermost gimbal component is only there to keep the joystick from being able to twist left and right and doesn't bear any of the load, it was actually put together out of 100% plastic. So you have two plastic components, one turning inside the other on these little plastic pins. And that's where the problem comes from, is that those pins get to where they start sticking in the plastic even with some grease. Now, the other Warthog rebuild guides actually have you sand down these pins to decrease their diameter a little bit and maybe sand out the holes a bit that they go into to try to make it smoother. But it's basically impossible to do that perfectly symmetrically. So I found that you wind up kind of making them a bit oval, and you have to keep sanding until they get smooth. It took a lot of time, and the results were satisfactory but not ideal. The method that I'm going to use here is a lot faster and will give you perfectly symmetrical opening of those openings. If you take these plastic pins, the smaller diameter portion toward the end is what actually fits into these holes in the inner gimbal component. And we want to get these to the point where there is basically no noticeable friction when you twist these inside those holes. As we're doing all this, it's a good idea to take a look at the gimbal components, run your fingers over them. This one is a very, very well used stick, so these edges have been kind of worn down over time, but you're looking for any rough edges where there are moving parts, and it's a really good idea to sand those down with sandpaper, probably starting about 240 grit, perhaps 180 if the 240 doesn't seem to be getting the job done quick enough for you, and then go in sanding steps up to about 400. I don't think I'd go any further than that unless you're going to be sanding the whole gimbal. I use a razor blade here in this guide, but that's not my recommended method. I had to be very careful doing that, but I didn't have any sandpaper on hand. And use some rubbing alcohol and paper towels and clean all of the factory grease off all of the components as best you can. That way it doesn't mess up your sandpaper or anything like that, and you have the removal of all of that old grease before you start putting the good synthetic stuff on that we're going to apply. Alright, now that the grease has all been cleaned off, we can go ahead and start cleaning up some of those rough edges. Now, if you want to sand all of the gimbal components here, this entire ball here, and then the inside of the upper part, you can actually smooth out your Warthog and you'll have less friction. It feels pretty nice, but I do think that there's a bit of a downside there on the retention of grease. And I know with mine, which I sanded down real smooth and even kind of polished up, I very frequently have to kind of move the stick around vigorously in order to spread the grease back around a little bit, it seems. But it does feel really, really nice, so you can consider doing that. Don't sand the outside of the upper gimbal component that the actual stick attaches to, just the inside. of that globe there and the outside of the bottom. Again, any rough edges that you find from the casting on any of these components where they move around, so on the outside of that bottom ball, especially here on the ends of this innermost gimbal component that we're working on, you want to get rid of any of those rough edges as much as possible just to smooth things out. I don't think this is super important, but it's a little bit of detail work that will make your Warthog feel a little bit nicer. This is where we get to the part of the guide that is the method that I came up with for eliminating the stiction and smoothing out the Warthog so you have less friction on that left-right axis. So I use, in this case, this is a 1/4 inch drill bit. You might also want to have a 15/64 drill bit on hand, which is 1/64 of an inch smaller. But I take the smooth end of the drill bit and I force it in there, which takes a lot of hand strength. I'm one of those people who closes jars and then nobody can open them. So I don't know if you will be able to manage to force this in here or not. But what we want to do is actually use the drill bit to enlarge these holes. So I wimped out a bit on this one because it belonged to a friend. I probably, after doing what I do here, I probably should have turned those drill bits around and used the drill end and opened up these openings even more. But if you have the 15/64 drill bit, go ahead and put the twist end in there with that and turn it by hand until it's smooth, and then pull it out and then do the hole on the other side. And what you do after that, and then trying to force maybe the smooth end of the 1/4 inch drill bit in, put that ball back into the base of the gimbal and install those pins, no grease or anything, just dry. Pop those in good and tight and make sure that they're flush up against the bottom ball gimbal, and see if there's any friction at all, if there's any resistance at all when you pivot that forward and back. It should feel like there's nothing there. It should have no friction whatsoever. If after doing that you still feel a little bit of resistance even, go ahead and use the twist end of that 1/4 inch drill bit to open those up even more. Now, if you get carried away with this and you wallow them out a bit and there's a little bit of play, it's not actually a big deal. This part does not have anything to do with the accuracy of the joystick. It doesn't have anything to do with a dead zone or anything like that. If you were to massively oversize these, get completely carried away, all you would wind up with is a little bit of wiggle in the twist of the stick, and there is no twist axis on the Warthog. So not a big deal. Something that you're going to want to avoid just because it'll feel nicer. But don't be too scared of going ahead and opening these up. Make sure you get it to the point where this thing pivots really smooth with no grease when it is fully installed with those plastic pins pushed all the way in good and tight. At this point, I actually got that 1/4 inch drill bit stuck in there on the smooth side to the point where I had to use the pliers to twist it back and forth and pull it out. So again, I really should have gone a little bit farther with this one, but I didn't have the 15/64 drill bit available and didn't want to go to using the twist end of the 1/4 inch drill bit without trying the 15/64 twist end first. If it was my own, I probably would have just gone ahead and turned it around and used the twist end of the 1/4 inch drill bit, because I believe that's what I did for my own personal one. But again, I just didn't want to take any risks with somebody else's hardware. Now you see I'm test fitting these just by putting the pin into the ball to see how it feels. I didn't think to do it at the time, but once I got to where I was satisfied with the way that these felt, I really should have reinstalled that like I described a minute ago. Actually put that ball in without any grease and installed those pins and checked to make sure that there was no friction, no noticeable friction whatsoever, rotating that thing back and forth when it was installed before I applied the grease and installed it permanently. Now on these plastic pins, you see there's kind of a shoulder there where the smaller diameter piece then gets bigger for the larger diameter part that gets pressed into the outer ball. You need to be careful with those when you're test fitting them in without actually having the ball installed into the gimbal. Those shoulders, if you push the pin in, are going to be creating friction, and it'll feel like it's still sticky when maybe it's not. That's why it's really important to test it with the ball installed, which I don't do here in the video clips. Now we're going to go ahead and start greasing up the gimbal. I am very heavy on the grease when I put these together, as long as you don't get it to where you have grease that's going to be interfering with the magnet and the Hall effect sensor. I don't think there's any downside to having too much grease, but there certainly could be a downside to not having enough. So I do go very heavy on the grease here. You probably don't need to put in nearly so much, but I figure in this case more is better, as long as it's not sloppy and getting into the actual sensor assembly. Here I'm actually trying to fill that hole with some grease. So I'm kind of swiping some in there to actually fill the hole, so that when I push the pin in, there's one extra way of trying to make sure that we get as much grease as possible, because this is where the stiction comes from. It's the friction of that plastic pin in that plastic hole on that innermost, smallest gimbal component. So we want to make sure we get as much grease in there as we can, in addition to having opened up the clearances on it. If you filled those holes with grease the way that I did, you'll see when I push in the pin, I get kind of a pillar of grease that got pushed out. So I'm going to take something, I think I used the screwdriver here, stick it in there, and very carefully just grab that blob of grease with the screwdriver, and I'll do that for each of the 2 pins that I pressed into a hole full of grease. Once you have that assembled, you really want to make sure that those pins are pressed in all the way good and tight. It's probably a really good idea to use something like a pair of channel locks and maybe a rag or something like that to protect the plastic and give it a really good squeeze. You want to make sure that they are in all the way. And again, make sure that you do not feel any resistance whatsoever to pivoting that inner ball back and forth on those 2 plastic pivots. Once you have that done, it would be a really good idea to take your paper towel and rubbing alcohol and clean off the outside part of that bottom gimbal ball really well, and go back with your sandpaper and sand down where those pins are pressed into the ball, and try to get that as smooth as possible. There will be a bit of an edge there. That's going to add extra unnecessary friction. Again, I don't actually do it in this video clip here, but I do strongly recommend doing that before you go ahead and continue greasing up that component. Now I'm trying to pack as much grease as I can in between that inner gimbal ball and the outer gimbal, just so that it kind of works its way in over time instead of starting to go dry. Now we're going to grease up the inner surface of the top ball. Make sure that you apply grease all the way up into the ball, around that whole lower section that you kind of see me rubbing it onto there, where it's got a different angle to it, a different bevel to it, and also onto the bottom flat and shoulder there. If you get any grease on the magnet there, just go ahead and wipe it off afterward. You don't want any grease making its way down to where it winds up between the magnet and the sensor. Clean up those wires as well. Try to get as much of the grease as you can off of them. And again, it's redundant, but before you put this together, I would actually advise rubbing a bunch of grease onto the outside of that lower ball as well. Again, I didn't do it here. I'm not sure why I didn't. I was probably just a bit distracted. As you push this on, the wires that are coming down from that top gimbal part are off to the one side of the magnet. There is a corresponding gap in that innermost ball that we worked on, and you want the wires to be on the same side as that divot that is in that innermost gimbal, so that they are not going across. If you look at it closely, it should be pretty self-explanatory. And once we have that carefully pressed down in, it'll kind of snap into place. I'm going to go ahead and clean out the sensor well there as best we possibly can. And then we're going to start greasing up and preparing the rest of the components to get installed. The other modification we're going to make here is actually enlarging the holes here in the spring plate that ride up and down on those 4 shafts on those springs. So after I did this job the first time, I don't know if it was the grease or what, it went together and everything was perfect initially, but after a week or two of use, I noticed the joystick started binding again. I was getting extra friction. And when I took it apart and inspected it, I tracked it down to these openings being too small. So I think that this white material, whatever it is, might have swollen somehow from the grease. So what you want to do is take your 1/4-inch drill bit that we used earlier and just go ahead and take the twist end and open those right up. It should make them just about perfect. Make sure that they're nice and smooth. Just keep spinning that drill bit until you're sure that you've got those holes nice and smooth. And then of course clean away all of the debris and scraps afterward before you start greasing this up. Let's go ahead and install the spring plate onto the shafts there with the 4 little springs underneath. Now, it's pretty easy to get this misaligned, so if it doesn't really want to go on, then pick it back up and check again. Got to make sure that those 4 shafts are coming up through those 4 holes that we enlarged with the drill bit a couple minutes ago. Clean the grease globs off the top of those shafts because you're going to be putting screws into them. If your stick is new or has a good rubber ring in it that hasn't started delaminating, I'm hoping that greasing it up real well with this nice synthetic grease will prolong its life, and so far I haven't had any problems with my own, which I did all this to when it was brand new out of the box. So go ahead and grease up that ring real nice. Should also soften the center bump a little bit. Again, if your center ring, if this rubber ring is damaged on your joystick, a lot of people are just running without it, and it just makes the center bump just a tiny bit harder. Doesn't seem to be any sign of any problems with wear or anything like that going on. It's just there to soften the sort of impact when the joystick gimbal bumps up against the spring plate to push it into a different direction. This shoulder here on top of the uppermost gimbal component we're greasing right now, that's actually what is taking the load when you are moving the stick. So whatever direction you push the stick in, the opposite side of that will become the highest point, and that pushes up on the spring plate, and the spring plate in turn compresses the large spring, and that is what gives you your centering, your spring centering, and your resistance on the stick as you pull on it. So again, this is actually what rides on that rubber O-ring if it is intact, and if not, it'll just ride directly on the plastic part of the spring plate that is underneath where the O-ring is, if that's missing. At this point, if you want a little bit better understanding of how the joystick centering works to troubleshoot any future problems or anything, if you hold that spring plate down with one hand and move the gimbal around with the other by grabbing the threaded portion there and moving it around, you'll see how exactly the gimbal pushes upward on that spring plate. And now we install the large spring, which is going to be pushing down on that spring plate. And when you move the stick, you're actually pushing up on the spring plate, and in turn compressing that spring. Now there are a lot of people who like to remove that large spring from the Warthog. After doing this, I really don't think that that is at all necessary. I wound up going back. I ran mine without the large spring for a very long time, and I wound up going back to running it completely stock, other than smoothing out the gimbal with some sanding and polishing, and making the little modifications that we did here in this video. I think that the spring tension and the centering is actually more beneficial than it is detrimental. Everybody, including myself, get pretty wrapped up in trying to reduce the center bump and the spring tension for centering. And in the end, after a lot of playing around with things, I found that I flew better if I had the full centering force and a proper center bump. I did have a U2 NXT modded Cougar, which is considered kind of the ultimate joystick for the PC, and they're pretty desirable and hard to come by. It has no centering bump whatsoever, and I was actually performing much better flying in terms of accuracy, and also racing in Star Citizen, where you need a lot of accuracy on where you're flying, with the Warthog done up this way. Grease up your spring next. I'd like to grease the top and bottom coils in particular. Now we're going to start final reassembly. Note that this outer plastic housing has those 4 rubber pads, which I have greased up, and that they are on the top of the ring there. And you will see this yellow arrow, and the yellow arrow there goes opposite the where the USB cord comes out. And note that the yellow arrow goes on the side of the connector with 2 pins. So if you assembled your gimbal correctly, the 2 pins side of that connector for the stick will be opposite the little gap in the base for the USB cable to come out, and that yellow arrow should be lined up with the 2-pin side of the connector, the 3-pin side facing forward. Now we're going to go ahead and grease this up. I think that there theoretically, I don't think is any actual contact, is not any actual contact going on between the top of the gimbal and this part here. However, just to be safe and to reduce any possible friction, I do go ahead and grease that up, even though I tell you guys not to sand that top gimbal component. The outside of the top ball does not actually bear any load. It's actually the bottom outer ring of it against the spring plate that is bearing the load. Go ahead and install the top cover. You're going to get the large holes lined up with those 4 posts that stick up and have the springs on them and then are coming through the spring plate, and you put the 4 large black screws into those 4 posts to secure the top cover. There's a lot of spring force pushing up against you while you're doing this, so you're going to have to use a hand to hold the top down very firmly while you get the first 2 in, one opposite the other, and then after that it's held in place for you to reinstall the other pair. Now that that is assembled, just go ahead and clean off any grease that's anywhere there visible, anything that you got on it, and you can clean out, and you can move the gimbal to the side also and clean off any grease that perhaps got onto the top surface of the top ball gimbal. Let's go ahead and flip it over to do the assembly on the bottom here. And again, just clean out any excess grease that you possibly can there before you put the sensor in. We don't want any grease getting onto the sensor and causing any inaccuracy. Installing the pillar for the hall sensor, you'll see there's the large opening in it there for your wires, and we want to line that up with the black marker spot that we put in there to mark where it goes to make sure that it is rotated around in the correct direction. And the wires that are coming down from the stick should be through that opening. These screws, these are the 2 longer screws that are still left, and you want to be very, very careful putting these in. They are very, very easy to strip, and they are very, very important. So you barely want to tighten these, just barely snug them up with a screwdriver, and definitely do not use any power tools here. We also have the 2 marks that we marked for which side the little circuit board goes onto. So you want to put that back in place based on those marks that you made earlier. And go ahead and secure that down with the 2 short little silver screws. And then secure your 2 little ground straps with the 2 large silver screws. After you're done getting this all put together, just go ahead and clean up the whole housing, get all the grease that got smeared around on it off and everything. You can use a paper towel with some rubbing alcohol again. It should clean it up nice. Alright, and the last thing you're going to do here is just go ahead and install the trim ring back on top with the 8 little chromey screws there. And you are done. Your Warthog should now be nice and smooth with the stiction gone forever. And it should feel better overall. If you want to take the time and effort to go ahead and sand those gimbal components down so that you remove that textured surface from the moving working parts, that'll make it even smoother. It'll have a similar effect to putting in a smaller spring. You will need to recalibrate your Warthog afterward using a tool provided by Thrustmaster. Do not use the Windows calibration. You want to use Thrustmaster's little program that they provide. They will give it to you if you contact their customer service, but they don't have it on the website. However, it has been posted all over the internet for you to use, and I will put a link in with the YouTube video for you guys to find that. Once again, guys, I'm Trip Rodriguez. Thank you for watching, and let us know in the comments if this guide helped you out.